So first of all, welcome to the panel. I think we have a very nice group of panelists and an interesting topic to talk about. So we're going to be talking about batteries and energy storage, which on one level seems like kind of a technical and maybe sort of minor topic, but I think I would, thinking more broadly about it, it's actually energy storage is a very fundamental, plays a very fundamental role in the energy supply. And if you think about it sort of broadly, what energy storage allows is really the decoupling of the production of energy from the consumption of energy. And that, decoupling takes place both in terms of spatial decoupling. So, think of your cell phone or your laptop. You can, use energy generated somewhere and take it around with you and power devices that are relevant, or electric cars, things of that sort. And also separation of production and consumption of energy over time, which is extremely vital in terms of integrating sort of intermittent renewable energy sources like wind and solar and things like that. So in many ways, storage is really at the heart of making a lot of sustainable energy technologies viable. And we have a great group of panelists to talk about that. And also, just one more thing to kind of frame it is to think of, energy storage takes place on different scales. Like there's, small scale energy storage, small electric devices, handheld devices, all the way up to, bulk electric storage that's, sitting off the grid and moderating the entire energy supply on a large regional grid. So that's, so that's the topic we're going to talk about today, and we're going to talk about sort of what are the roles for energy storage currently, kind of going forward. What are the challenges for the technologies that are available for energy storage, and try to look at the impact of energy storage on building a more sustainable energy supply. So before we get into questions, let me just introduce our panelists. So we have David Edelson from the New York Independent System Operator. They're the group that runs the spot market for electricity in the New York area. And so he's very involved with the operation of the grid and the role of energy storage in the grid. We have Rob Mosher, who's Director of Product Marketing for A123 Systems. They're a maker of lithium-ion batteries, so he's an expert in the battery technology area. And then we have Shayne McQuade, who's with Voltaic, and they're a producer of consumer portable devices and solar panels for solar panels both for developing economy applications and for mobile charging applications. So much more on sort of the micro generation and storage end. So I think we have a nice coverage. And so maybe before we get into questions, I'll just have each of you describe your businesses a bit, and then we can kind of start with a few questions. So, Sean.
So, Shayne McQuade, I'm the founder and CEO of Voltaic Systems. Voltaic started out about 5 years ago as an idea. I came up with the idea for a solar bag, and essentially it turned into a business. What it does is you have solar panels on the outside of your bag. It operates actually like a solar house, off-grid solar house. You have a battery inside that's storing the energy, and then as you need to, you plug into whatever device you're charging. In this case, cell phones, cameras, iPads. In the case of some of our other bags, laptops. What we're now doing is moving into solar lighting. So this is an example of a solar light that we're working on. And this is primarily targeted at developing countries. There's an interesting phenomenon emerging where almost 2 billion people don't have electricity in these countries. A lot of the time they're using kerosene for lighting, and we've now got to a point where solar, battery technology, and LED technology are evolved and cheap enough that a solar light like this can begin to compete with a kerosene lamp. And over the next sort of decade, we're going to see really potentially 1 billion people switch from kerosene to solar.
Okay, David.
I'm Dave Edelson. I work for the New York Independent System Operator. Most people aren't familiar with what independent system operators do. In the late 90s, when the country was trying to deregulate most of their electricity markets, the federal government set up these independent system operators around the country to coordinate the generation and consumption of electricity in various regions, as well as coordinate the buying and selling of electricity. So, for example, I guess down here, Con Edison would be the utility. Every minute of the day, Con Edison is buying electricity to serve their customers. They may have bought this yesterday in advance of today, knowing what they needed, and then to make up any difference, they might be catching up or making up for the shortfall in a minute-to-minute spot market. The New York Independent System Operator operates those markets. They're like financial exchanges for electricity. At the same time, we're also scheduling and dispatching generation throughout the state to support the needs of a Con Edison and directing that electricity to the end-use customers. So while we don't own any specific assets, we have under our control of dispatch and scheduling a variety of generating resources, including storage. And storage at the bulk grid level, which is really what we deal with, is a variety of different types. You've got battery storage that can store energy and discharge it on a very short-term cycle. You've got storage that can last for many hours on end. Hydro storage, pump storage, where you pump one reservoir from a lower elevation to a higher elevation, where those pumps are using electricity so that they can then flow that water back down and spin a turbine to generate electricity when the electricity is really needed. We have some large plants like that can run continuously throughout a day, because you can imagine the size of a reservoir, how much of a fuel resource that water can be for them. So we deal with a lot of different varieties of storage. We are constantly balancing the load or the consumption with all of our generation, including our expanding portfolio of renewable resources like wind. We don't have any solar actually on the bulk grid in New York State, but wind is a very variable resource, as most people know, so it's moving constantly. Not completely unpredictable, but it's moving, so we need to actually adjust our generation mix or our load consumption mix constantly to keep up with where everything is. They have to remain in balance. So the more flexible our system, which storage gives us a lot of extra flexibility. If we're generating more than we need, we can either back down our generation or we can store it for later when we really need it. Those are the types of activities our company's dealing with, and it's very intertwined with those financial market rules for buying and selling of electricity.
Okay, thanks. Rob?
So my name is Rob Mosher. I'm Director of Product Marketing for A123 Systems. A123 Systems was founded back in about 2001 with technology that came out of MIT. And actually we started with a Department of Energy grant of about $100,000. Last year we went public and raised about $400 million. We employ about 1,700 people worldwide now with manufacturing plants in Massachusetts and Michigan and in Asia as well. And we've just recently received a $250 million grant to build out additional manufacturing facilities in the U.S. to build this very strategic technology in lithium-ion battery technology. We're really focused in three market areas. We're focused in transportation, so building batteries for electric vehicles, hybrid electric vehicles, as well as hybrid buses and trucks. And then commercial applications is a second area where we're putting batteries into cell towers around the world, for example, where traditionally lead-acid batteries are being used, and lithium-ion can be a better choice in some cases because they last longer and they reduce overall life cycle costs. And then the third area is really the grid, and that's really my area of focus. And I'd actually, like to compliment David and the New York ISO, as well as a lot of the other ISOs, are being very proactive in their adoption of and acceptance of new technology, and trying out not only new technologies such as batteries, but flywheels and other technologies to try to improve the efficiency and reliability of the grid. Today we've got about, A123 has about 20 megawatts of grid-connected storage, with about another 60 megawatts planned over the next year. And we're in production today. We're commercially available. This isn't just PowerPoint slides. It's stuff that's shipping today. Our standard grid product is if you can imagine, it's a tractor trailer sized battery pack. It's 53 feet long, about 9 feet across, 9 feet tall, and we actually ship it as a system on a tractor trailer. So one of the other benefits is that it is somewhat portable and can be moved to wherever the need is on the grid. Today, it's primarily being used in places like the New York ISO for a service called ancillary services, the very short-term balancing of supply and demand on the grid to maintain, for example, frequency and voltage right where it needs to be in order to provide us with stable power. But it can also be used for the firming and smoothing of renewables. You may know that wind and PV can be very intermittent, and that creates new challenges for grid operators. So the battery can be used to smooth out that output that comes out of a wind farm, for example, or out of a PV array, and provide very steady, predictable power onto the grid, and replace alternatives such as adding, in some cases, the solution might be adding a gas turbine generator for every windmill you put up, which to some extent goes against part of the purpose of putting the windmill up to begin with. So adding a battery provides another cleaner, more efficient way to smooth out that output. Batteries can also be used on the grid for congestion relief. There's some areas on the grid that get overloaded circuits, transmission lines, distribution lines that can get overloaded at certain peak periods of the day. And it takes a long time to put in a new transmission line, for example. And so a battery can be a way to solve that problem quicker and in some cases more cost effectively. And then other benefits of putting batteries that you can put them pretty much anywhere. They're quiet, they don't make any noise, they don't produce any emissions by themselves. So we think that there are a lot of applications on the grid where a battery can be used to improve the reliability, improve the efficiency, reduce emissions, and overall improve the grid. And that's about it.
Okay, that sounds like a big battery. Yeah, I'd like to see a picture of that. Okay, so I guess one thing maybe, you guys have touched on it already, but is to think in terms, like what, in your view, are sort of the really big opportunities for energy storage as like a market and a technology, and both at the large scale and small scale. Maybe Shayne, you can say.
Well, I guess I should start with the small-scale consumer devices, since that's what we primarily deal with. And basically, battery technology has lagged behind the development of the devices, so that what our cell phone can do now is dramatically more and consumes more power than it could do in the past. But the battery technology has evolved, but it hasn't maintained pace. I think for consumer devices, what the technical evolution of batteries will mean is basically they'll get smaller, they'll get lighter, if we're lucky they'll get cheaper, and I think at the margin we'll get devices that currently consume too much power to work as battery-powered consumer devices might begin to come on stream, but I think they'll be at the margin, so that might be projectors or refrigerators and things like that are too power hungry at the moment. But really I think it's the developing world where batteries could have a huge impact or will be part of the picture. Those 2 billion people that don't have electricity at the moment are expected, to be making a choice over the next decade. And much as the cell phone network has sort of leapfrogged the traditional wired telephone grid, it's expected that electricity generation will do the same. So in countries where there is no national electrical grid, and there's not likely to be one, people will go for locally generated power, and that'll typically be at a household level, at least initially, because already the government's failed and communities have failed to deliver any sort of greater system. So people will be looking for solutions, and what they'll be faced with is 2 choices. Either they'll be going for diesel generators, or they'll be, at burning fossil fuels or at best biofuels, or they'll be looking for the most likely sustainable smaller scale systems, which are primarily solar and potentially wind on a small scale. And so batteries fit into that picture in that you can't have an off-grid solar or wind system unless you have batteries, because the sun is not always shining, the wind is not always blowing, and so you need a battery technology to store that power. Now, it's largely there, but the economics of it don't necessarily work out, and so it'll remain to be seen what happens over the coming decade as to which wins out, but batteries will be key to the answer.
Okay. But David, from your standpoint?
Again, when I usually refer to storage, I try to specify exactly what, because there's very different technologies that impact managing the generation and the load on the bulk grid. We recently studied, the New York ISO studied the effects of increasing wind generation in New York State. Wind is a challenge for an independent system operator or any utility that has to balance load and generation, which has to be maintained because the wind varies, so the output of those plants vary, but the consumption is following a more regular pattern, so you need to keep those things aligned. So we recently studied, as we increase the wind penetration as our generation mix in New York State, what does that mean for reliability? We can't have the lights go out once a year. We're not allowed. It's actually unacceptable. I think we're allowed one every 10 years. I think we've already done that in this decade. So.
Right.
And I'm not talking the local lines, which kind of does all the time. I'm talking about the bulk statewide Eastern Seaboard type of blackouts. For everything, and so our conclusion, we're talking about opportunities for storage. We have a market for short-term storage. We call it, well, you mentioned it as ancillary services. We have a name for a specific product called regulation, where these units can move very quickly to really keep that balance of generation and load in line. These units that can move up or down every few seconds per our instructions to keep statewide this balance. So as we get more wind, our balance of generation gets more variable. So it's harder to keep that in balance. So what we concluded, and there's a market for this regulation where companies such as Rob's would get paid for the regulation service that their batteries can provide on the bulk grid. For every 1,000 megawatts of wind increase in the state, we need to correspondingly add a 10% increase in the amount of regulation that our company buys, which Con Ed actually pays for and all the other utilities in the state ultimately pays for. So opportunities, this is why you always hear about storage going hand in hand with renewables, because some types of renewables, while they're great, very, very clean, free fuel source, don't emit anything, create challenges for maintaining the reliability of the grid, so you need other things, and it doesn't necessarily have to be a natural gas plant that's backing up every wind turbine. It could be a lot of other technologies that just can be considered more flexible. And from the New York ISO's perspective, we just care about having a flexible mix of generation resources, be it a battery, be it a flywheel, be it pumped hydro, be it natural gas in some extent. That's an opportunity on the short term. And then in general, again, our company's balancing load and generation, and we're predicting where the load or the consumption is going, follows a fairly regular pattern where, around 6:30 in the morning, 7, consumption's picking up as people are waking up, turning on their lights. It peaks in the middle of the day. It drops a little bit towards the end of the day and then peaks up again when everybody gets home and turns on their lights again. So, and then it reaches its crest at like 9 p.m. and then starts going down at night. For wind, it happens to be really windy, usually overnight when we don't need as much generation. So this is where longer-term storage that can actually consume a lot of that cheap energy that wind plants are generating that the state might not need, it can start to consume that. So essentially it's changing the curve. Because if a storage device or a storage plant, pump storage, something can consume and shift that curve so that it's not as high in the day and not as low at night and flatten it a little bit more, there's an enormous economic change there with what kind of generating plants you need to build in New York State. You need a certain amount of reliability. If you can store that energy, which we've never really been able to do in great quantities with the exception of pumped hydro, the more flexibility you have to store it and shift that demand curve, you're actually lowering those peaks by using storage. It saves everybody money as far as the types of generation mixes you need, reduces emissions because you're not turning on those diesel generators as much during that 2 o'clock, 100-degree day in the middle of the afternoon. That happens 3 times a year, but you need to have those diesel generators around just for those 2-3 hours a year. You now have batteries that have stored that energy overnight and can deliver it on demand during the peak time. So, and those are all valuable opportunities for various types of storage, but you got to think about the time frame of what that storage is delivering to see what kind of products and markets are available to them.
Yeah, so Dave, can you just say something too? I mean, we had about, I mean, since you're at the kind of the epicenter of the grid, like what you guys are thinking in terms of if there's widespread deployment of electric cars and things like that, and how that would affect the energy infrastructure?
Yeah, we've actually, and not just New York ISO, all the ISOs have started evaluating and analyzing this. I think there's been we've done white papers. There's been studies. If you go to our website and search for plug-in, you'll see actual white papers that have done by other consulting groups. What that does, let's say there's an enormous penetration of plug-in electric vehicles, and everybody gets home and plugs in their cars at 5 p.m. Well, that's already a time where demand is increasing really fast for us. So you add on top of that, that creates some challenges. So where it's helpful for us is to be involved, and where we care is trying to shift that demand to later at night. I mean, it's great that people are plugging in if they're charging overnight. That's great, but let them plug in at 11 p.m., not at 5 p.m. You know, so the timing of that widespread demand, it would be automatic that people would want to plug in at 5 when they get home to charge overnight. There's lots of conversations with utilities and car manufacturers about talking about when, controlling the charging cycle. So they can plug in at 5, but it might not actually really kick in until, maybe it becomes price sensitive. We're sending, or Con Ed is sending to the consumers, here's the price of electricity. Right now, most people are price insensitive because you pay a flat rate no matter what time of day you're using electricity. A lot of people are talking about more dynamic pricing and price sensitivity to make consumers care about it. It's definitely more to my advantage to charge from 11 to 6 than it is from 5 to 10. So whereas my company would probably not, at least in the next 5 years or maybe even 10 years, ever connect directly to the batteries in cars in the next 5 years for sure, where we're controlling it, saying now you can charge, now you can't. We care about the policy and the manufacturing of these for what it means to the bulk grid if you have 3 million people plugging in at the same time. Long term, there's been a lot of discussions when you think about a battery like what A123 does on a much smaller scale in a car. If we have 2 million of those cars available to us around the state plugged in, if we could control them, that regulation service now gives us an enormous amount more flexibility. We can say, it's a fundamental mind shift for everybody to say, I'll let the bulk grid control my battery, giving me back electricity. But I mean, you've got policies have to be developed, meters have to be worked out to make that all work. But if the management of the bulk grid could involve drawing upon 2 million car batteries when it needed it and charging it when it doesn't need it, that's a whole fundamental shift that people are really exploring for probably 10 years down the road. But that you can imagine what that could mean.
Decentralized storage.
Decentralized storage, decentralized generation on the spot. Then it gets more, obviously, more into your world.
Yeah. So, Rob, can you say a little bit on the electric vehicle market? For how do you view that as a market for storage and batteries?
Well, it's obviously a great market for storage. There's, it's an area that we're.
I mean, how big are you anticipating that's going to be? Are you?
How big?
Yeah.
It's going to be very, very large. There's just so many vehicles out there that are sold every year. If you think that, and it's been a little while since I've thought much about spent a lot of time thinking about the transportation market, but, if you consider that, if only 10% of vehicles become electrified, that's just such a large number of batteries. It's a huge market, and so that's why you see just a tremendous number of competitors jumping into that market. So, we're in that market. A lot of the big players, the Japanese, battery manufacturers are jumping in very aggressively. The Korean manufacturers are jumping in very aggressively. All the biggest names in batteries are there because it's a tremendously large market and tremendously exciting. And again, it doesn't have to be that every car has to be electrified. If you can imagine that just 10%. I see. For me, most people drive. If you look in the U.S., most people drive less than 40 miles a day. So it's a perfect target market for an electric vehicle. An electric vehicle with a battery can go easily over 100, 150, 200 miles. So you wouldn't even have to plug it in every day. And it would allow you to get to and from work, plug it in the evening, at off-peak periods hopefully. And be a much more efficient, way to get your transportation, much more, much cleaner way to get your transportation, and would reduce dependence on oil. So it makes a lot of sense from my perspective. It makes a lot of sense from a lot of different perspectives.
Yeah, I was thinking, since you're the primary battery technologist here, what is from your perspective, what do you see as the main challenges in getting to the point where batteries are economically and technically viable for a lot more applications? Yeah,
so we were talking about this a little bit earlier. One of the challenges right now is cost. Batteries are expensive today. Lithium-ion batteries are expensive today, and so you talk about adding somewhere between $8,000 and $10,000 to your car. how many consumers are going to be. There will be some consumers that are perfectly happy to do that, but there will be, if we really want to penetrate mass markets, then that cost has to come down. I'm convinced it can come down. We're still in the very, very beginning of our scale curve. So as we scale up our manufacturing capabilities, costs are going to come down. I always compare, a battery, which is a relatively simple product that lends itself well to, very high volume manufacturing processes like, web-based coatings and, process-oriented manufacturing processes, to an internal combustion engine, which is, a very, very complicated piece of machinery with lots of very tight tolerances and lots of moving parts and, lots of electronics and lends itself to more, discrete manufacturing, more costly manufacturing types of processes. You have to believe that a battery is going to come down and be more cost effective over time than such a complicated piece of machinery. The other thing that will lend itself to getting costs down is that right now they're basically taking sort of existing automotive designs and just adding a battery and an electric motor and taking out the engine. So you're taking out something which costs $600 and throwing in a motor which probably costs $600 and then throwing a battery which costs thousands of dollars, right? So it's going to cost more, but over time, that whole system, that whole platform will get more optimized, and you're going to be able to take out all kinds of other costs associated with that vehicle once you move to the motor and the battery-based design. So I'm confident that will happen over time, and I think that's probably the biggest challenge, and it's just a matter of time to get to where we need to be.
I mean, do you see? I don't know. Do you see much competition from other like hydrogen, for example, as an alternative for storage and transmission? We have one panelist that wasn't good. Couldn't make it, who does fuel cell work, so that would have been a good question.
Yeah, hydrogen's very.
But compelling. I mean, when you look at it from a market standpoint,
hydrogen's very compelling, and the idea of hydrogen looks great. The challenge is that technically it's very, very challenging, and people say that we've been 15 years away from having a commercially viable hydrogen fuel stack for quite a while, and I think eventually we're going to get there, but it's going to take some time. And by the way, we're perfectly happy as battery manufacturers. We're perfectly happy with hydrogen fuel cells becoming viable because you still have the battery in the car, whether it's like a little diesel engine or a little internal combustion engine of some sort generating the electricity that then gets used in the
like a hybrid. Right?
It would be a hybrid basically, right? Yep.
Okay, so maybe one last thing, just to open up before we open up for questions. Just any thought? This is a sustainability conference, so any thought on the role of storage broadly for making energy more sustainable?
Well, transportation's a big one. It's obviously a large consumer of energy, and essentially you're locked into fossil fuels in automobiles unless battery technology gets to a point where that becomes a dominant solution. And that in itself is not necessarily sustainable. You could still be powering a car with electricity that's generated from coal, putting that electricity in the battery, running the car. There are efficiencies along the way, I believe, and you waste a lot of energy just burning fuel. You can capture, if you have a coal plant, you can capture a lot of emissions at that plant that you might not necessarily capture at the car. But what battery technology and transportation allows you to do is then to substitute sustainable energy sources. So until there are electric cars or fuel cell cars, it doesn't really make any difference. It's effectively battery technology. You can't be introducing a lot of wind or solar power into running automobiles. So I think that's sort of a significant impact. There's a huge impact in the developing world, obviously, in the markets we're talking about. If you look at this lighting product, we're trying to compete in this case with kerosene. Kerosene lights produce about 100 kilos of CO2 a year. A product like this will produce about 10 kilos just to make the product, and then will last up to about 5 years with a couple of battery changes. And so a very significant difference in the environmental impact if you can substitute from dirty power sources to clean. That's much more so in the developing world, I think, than here, because you're more likely to be burning kerosene or having, household diesel generators that are probably not that efficient and clean and so on. So I think, huge opportunity for sustainability by virtue of the ability to use sustainable power sources.
Roach. So, David, in terms of the, what's the role, for, you have renewable portfolio standards and things like that? Or is it an obstacle to, I mean, storage is an obstacle to getting to, a bigger mix of renewable sources for the grid?
Well, New York State has a renewable portfolio standard. Yeah.
But I mean, I'm just curious. Is it more the, or for example, like you were mentioning about the leveling of the market for electricity? I mean, does that make the economics of renewable sources more compelling if you have kind of a flatter wholesale tariff for electricity?
I think, well, again, we have two focuses: reliability and then the wholesale markets themselves. But I mean, the big challenge of managing a grid is, as I've said before, you have to keep the consumption and the generation in line, second to second, all day long, every day. So, who's using it and who's generating it, what they're how fast they move, unpredictably matters greatly to us. When you add storage to the mix, it takes a lot of that dependency out of the equation. Without being able to capture some of that energy, which we can use, I think I keep hearing the word smoothing, or you can flatten some of that variability and make managing it a lot more, a lot better. So that so I guess what I'm saying is that balancing requirement we have today with the mix of generation we have necessitates certain technologies in generation, including very flexible natural gas plants, which are, while they're cleaner than coal, are still burning a fossil fuel and emitting things that we don't necessarily want emitted out there. Storage allows us to be less dependent on those technological standards that currently fossil fuels are the primary source of that flexibility for us.
But to your point about so leveling this curve, does somebody contemplating building a wind farm, if they were facing a flatter price for wholesale electricity, would that influence economics of that?
Yeah, actually, what influences economics, so a great example, I think Ford, yesterday was, I don't know what it is down here, but it was extremely windy about 4 days ago across the state, and we were generating about the maximum amount of wind. All the wind plants were generating about the maximum they can all generate across the state from 2 a.m. to 5 a.m. We had certain conditions where the consumption wasn't high enough in the middle of the night to support that level of generation. So we had to curtail them.
Yeah.
So we have to tell them to back down. So what they actually do is they can feather their blades so they're generating less than they're capable of, which means they're getting paid less than they're capable of. If you had more storage capabilities, as an example, where you can shift that demand more to the night, they could have still gotten paid. So that's where it affects the economics. They could have still gotten paid. That energy would have been stored and then delivered back maybe in the middle, again for the longer term storage, delivered in the middle of the day when the prices were much higher and the wind had already died down and the wind generators weren't producing much anyway at the time. So that's really the prime example. And it happens all the time. It happened just a few days ago where for 3 hours they were asked to back down because of not enough load on the system. So storage gives us more load in that sense.
Yeah. Okay. And Rob, what do you, from your standpoint, in terms of the sustainability impact of what your technology does?
I think our technology is one technology, among a host of new technologies that need to come online to solve what's going to be a global energy problem over the coming 20 years. I think China is already at approaching a terawatt of power, and they're just starting on their trajectory towards a large middle class, right, and consumerism similar to the Western world, right, and so that is going to create a huge sort of tensions around global energy resources, right. So without bringing just tremendous amounts of renewables to bear around the world, it could lead to bad things, right? And So I see the future for renewables to be incredibly important, and I think storage, including our technology, is going to be a big piece of helping to not only improve locally environmental conditions, but globally to help ensure that we don't end up in a global energy.
Yeah. I'm just curious, because you mentioned several rounds of pretty significant funding for your business. I'm wondering, when you go out to raise that money, what is your forecast for the market for storage technology? I mean, is it are you looking at a world where this is going to be a huge component of, rather than just a niche thing for selected applications?
It's generally recognized that the automotive sector alone is going to be very, very large, and I think that the what we're calling the grid sector could be a tens of billions of dollar type of market, not just batteries, but storage in general, right? And some portion of that will be addressable by battery technology, such as our technology. So it's a big market. The automotive by itself is billions, hundreds of billions of dollars of opportunity, and it's being driven by really fundamental forces in play. So.
Okay. So we have about 15 minutes left, so maybe we'll just open up for questions.
Yeah, actually, I have a question. So you're talking about sort of balancing out the grid a lot by batteries. I've read a lot about how sort of inefficiencies in transmission systems created by the balkanized grids that we have in this country, and having a grid that's primarily alternating current as opposed to direct current prevents a lot of this stuff. Putting aside all the regulatory issues and sort of political issues of getting it done, technologically, let's say we're in China, how feasible would it be to attack these problems by focusing on transmission as opposed to storage? So, your New York example, having a national grid, say, how much would that take care of the problem of having to thin out the grids?
Well, I guess one basic question there is how big are transmission losses as a percentage of output?
I actually looked that up.
How big is it?
In the country, it's estimated at 6.5%.
Yeah.
How big was it?
6.5%.
6.5%.
They compared their billing to their generating.
Yeah.
I can talk a little bit about it. You can probably talk more knowledgeably about it, but I can say that there's lots of different ways to solve problems on the grid today, and there's not one solution to these problems. It's not just storage. One of our founders came from American Superconductor, which creates these very, very high bandwidth superconducting cables that can lower losses over long distances over DC lines. The U.S. grid is actually not a single grid, but a couple of different grids with DC lines connecting them, and there's a lot of different theories about how to make that grid more reliable, more strong. One is to add some of these superconducting lines. Some of that technology is being employed in places like China as they build out. But another idea is to create more microgrids, right, where you're not so dependent on taking taking electricity over long distances, right? If you could have, to the extent that you have, PV, large PV arrays, right, you could have that, in combination with other, generating assets, providing energy more locally, right? And then you have a smaller grid that's more self-sustainable. That's not dependent on these longer lines that by the way might be in some cases considered to be a security risk, right? So there's different ideas, and the good thing is that all these ideas are being discussed. There are different pilot programs to test these various ideas, and it probably will be 30 years before we know where we're going. But
you had a question?
Yeah. So kind of picking up on the sustainability thread, a lot of the issues with these technologies, right, are rare earths and other metals and various components and pieces, and sort of that upstream supply chain where these things are coming from, where politically difficult areas, how they're being mined,
Right.
treated in those operations, etc. I'm just curious about each of your perspectives on where the industry
Yeah.
overall innovation and the R&D.
Yeah, no, that's a great question. There's a lot of nasty stuff that goes in batteries, right? The question is like, what do you?
Part of that too is how China plays in that too, right?
Yeah,
sure.
So both in terms of the extraction of those kind of
Yeah.
materials and then disposal at end of life, things like that. So
So I can talk a little bit about that, at least to at a high level. So they're all different kinds of battery technologies and all different kinds of materials. And I'm not familiar with them all. I know that not all lithium-ion chemistries are all the same. There's some which are metal oxide based that have some more expensive and more rare types of metals like cobalt, for example. In them, ours is what's called an iron phosphate variety, and so it's both less expensive and less toxic, I guess. I know that our batteries are about 95% recyclable. All the lithium is recyclable, like it can be recovered. So, Argonne National Labs has done studies which are publicly available. That they've predicted sort of with the growth in the transportation sector largely is driving most of the demand for lithium-ion chemistries for batteries. They've looked at sort of the ability of mines, for example, to be able to ride that lithium. And what happens over time is as you get more and more out there, the technologies to recover and recycle lithium become perfected. Plus, there's enough out there to make it worthwhile to recycle. And so even though the demand for electric vehicles goes up, the demand for raw native lithium plateaus, because you get this sort of like aluminum. You can start to recycle aluminum cans, and that provides a lot of the aluminum for new cans being made. So same thing with the lithium-ion batteries to a large extent. Can we do? I'm sure that there's more that will be done and needs to be done to address some of the other issues you talked about. We're just starting down this path. So I think that there's obviously going to be pressure on our company and other companies to make sure that the best techniques are being used in the mining practices, for example.
Actually, I'm curious about Shayne's reaction to this, because also I'm thinking like in the developing world, what happens when it's flooded with nickel metal hydride battery packs all over, and how do you think of the life cycle effects of that, or if there was widespread adoption of that?
I certainly think of it, and I think it's a serious issue, and I mean even here it's a serious issue because we're producing all of these batteries, and although the manufacturers of consumer electronics are recognizing it as an issue and mentioning it as sort of on the list of features and so on, and even starting to develop take-back programs and so on, it's really still feels like it's in the infancy. The manufacturers of laptops don't have the legal obligation to take back all of the batteries they put out there, and the infrastructure is not in place to draw those back through, and it's not feasible to ask consumers to FedEx a used battery back to the supplier, so you've got to develop a system through probably the retailers back to the manufacturers and so on. And so it's hard enough here. In the developing world, I think it's significantly harder. And honestly, I don't see an easy solution to it. I think there are going to wind up being used batteries in landfill in these countries. I think they already are. I mean, cell phones have taken off around the world, and those batteries are not getting recycled in developing countries. I think the hope would be to choose the technologies that are least damaging to the environment, and unfortunately batteries are generally not great environmentally, but you do see opportunities to do that. So for example, the rechargeable AA batteries that you bought 5-6 years ago were largely nickel cadmium, and maybe it was a bit longer ago, but and cadmium's a particularly toxic material. Predominantly now what you see is nickel metal hydride, which is much less damaging for the environment and easier to recycle and so on. So I think from our point of view as a company, we'll choose whatever technology we can that's viable and not environmentally damaging, and then try and package it in recyclable materials and make sure our electronics are meeting usually the European standards, so that, you know, because they're the best standards and so on. But I think it's an issue. I mean, I think batteries are going to be out there everywhere. Probably the bigger issue is electric vehicles, because if they successfully take off in developing countries, and already in places like China you see a lot of electric scooters, then that's a huge volume of batteries that we have to worry about where they end up.
If I could comment on that, there are some companies out there that are doing some pretty creative things around, and it solves a number of problems. One example is Project Better Place, who some of you may have heard of, and their business model, part of their business model is to lease batteries, basically, so that, you know, the buyer of the car doesn't actually own the battery. You know, Project Better Place or some of these other companies that are doing it will actually own the battery. Part of the reason for that is it actually lowers the barrier to people buying more and more electric vehicles, because now they don't have to pay for that up front, that large capital cost up front. But the other advantage is that they can then take those batteries after they've, you know, say they've been in the vehicle for, say, 5 years, maybe 20% of the capacity is sort of used up in that battery, and that's not good in a vehicle, because, you know, as you use up capacity, your range on that vehicle becomes less and less. And so where you used to be able to drive 100 miles, now you can only drive 80 miles on that. So what they do is that they'll take back the battery, and one of the thoughts is that you can take that battery, which still has a lot of capacity left in it, it's still very useful, and put it into a grid product at you know, relatively low residual value, right? And get, you know, more value out of that battery, and, you know, that will solve
where
problems.
space and weight are less of a concern and things like that. Yeah.
Right, exactly, and so one of the benefits there is that it solves yet another problem, which is, you know, now you might be able to use batteries, which might be really good for some applications, but maybe, you know, if you bought new on the grid, it might be too expensive for some applications on the grid. But now, you know, just at its residual value, it can be used economically on the grid. And then, you know, from a recyclability perspective, it also puts that battery in the hands of, you know, a large
Small
corporation,
which,
you know, can control and can be held responsible for making sure that, you know, that's properly disposed of at the end of its life, or recycled in an appropriate way.
That's interesting. Yanni?
I think that's the real question for solar lighting, because it's pretty widely accepted that this transformation is going to happen in the developing world, and the challenge is to get the product out there. And we're still in the development stage, so we haven't fully tackled how we're going to distribute. It's interesting to look at what the opportunities are, and so you see everything from sort of NGOs that will take the components of a solar light to a local village and have them manufacture the light themselves as a way to presumably reduce labor costs and so on, to sort of commercial ventures, and D-Light is probably the leading example, where they're trying to produce lights that are commercially viable and en masse and at a $10 price point, so that it becomes competitive with kerosene. And then there's sort of a market segment that would be Red Cross, UNICEF, all those sort of organizations where they're running refugee camps and that sort of thing. From my point of view, I'm biased in favor of sort of market mechanisms, and so I think the cell phone example is a really good one, in that this penetration of cell phones that's happened in the developing world over the last sort of half a dozen years has been phenomenal, and you can go to the remotest places on dirt roads with no electrical grid, and where there was never going to be a telephone grid, and get cell phone access. And people are there with cell phones, you know, sometimes shared, sometimes there's one for a community or whatever, but the cell phone has made it to those markets, and people are able to pay for the use of it, even though they're on $2 a day. And it raises the question how they got there, because there weren't a lot of NGOs running around promoting, raising charity money in the West to go and buy cell phones for people in developing countries. And I think it's a really good example of the market mechanism working. It was a product that was useful enough and cheap enough to be drawn through the market to those consumers. And I think whatever happens in the NGO world and the UNICEFs and Red Cross and all that sort of thing, solar lighting will only become pervasive if the same thing happens. If people produce a product that is cheap enough and good enough to be drawn through the system. And so that's our objective, and that's the objective of some of the other competitors in the market. We'd probably start in a middle market, so places like Brazil, where you may not get to the very bottom of the pyramid initially, so you start in a segment where they have a little more money, and then ultimately as the prices come down and the adoption rates go up and the distribution channels are established, you can move down. But I think that will be the key. The only caveats I'd say are that you can smooth the way a little bit, because the upfront cost of solar light, even if it's $10, if you're on $2 a day and your alternative is $3 a month kerosene, that's a hurdle. And so microfinance products can help bridge that gap. And at a broader scale, micro utilities can help bridge the gap, where somebody might come along and install a panel that's significantly bigger, that will run multiple lights and cell phones and potentially televisions and so on, car battery, and they'll charge you on a monthly basis instead of an upfront cost. And so I think they're the primary mechanisms by which this will happen.
Okay, I think maybe we have time for one last question, I think.
I want to get back to the scenario of using storage to smooth wind generated electricity as a feed into the grid. How close is this to being a reality? From, so say for example, from the point of view of a community wind project that will be 5 megawatts or less, is this something that you can actually finance and you can put it into a business plan and you can say, and would that make it more attractive to utility? How close are we to actually, is there legislative infrastructure, policy infrastructure that actually supports this today, or is this still 2 to 5 years into the future?
I guess it depends on who you ask, but there's been a lot of studies on, I don't want to make the argument that smoothing out the wind by tying storage directly to a wind plant is what I'm referring to, again, from my perspective. But there's been a lot of studies about that, and I don't know of any installations where a renewable plant, like a wind plant, has also been developed and financed with storage on site, at least on a commercial level, which tells me it hasn't been proven to be an economic model yet. Storage on its own, standing on its own 2 feet, as part of an overall mix of generation in a grid, is what's getting financed and what's getting built and what's valuable. So I guess I'd answer your question by saying, going back to the example from a few nights ago where we were curtailing wind for 3 hours, at the same time we contacted, and I'm talking large-scale storage here, that pumped hydro storage that has the 2 reservoirs, and we turned them into pump mode. They might have had 2 of their 6 pumps going at the time. We asked all 4 of them to come up to increase demand so that we can get through this rough patch sooner. So it's not tied directly to the wind plant, but we have an independent operator like us who is trying to balance that load. And you have this all over the country where there's independent balancing authorities who are balancing this. So it goes on today on this large scale of storage. I've seen a lot of studies that have said it's more economically viable for storage to stand on its own 2 feet as adding to the flexible mix of generation in an overall grid than it is to be tied directly to a renewable plant. Although you may have a different set of studies or history that tells otherwise where it might be financially benefit.
I would agree with you. I think that in most cases where you can aggregate a problem and treat the problem as a system, it's more economically reasonable to solve that problem. So I would agree with your perspective, although I think that it is somewhat location specific. So there are some places around the world that where storage is being applied commercially, but there's sort of special cases. Like Hawaii is one example where Hawaii is adding a lot of renewables, and the utility is requiring new wind developers to add storage, or at least to provide a guaranteed output that stays within some envelope of variability. And so one solution to that is to add storage.
That's a great example. Hawaii's, you do have to think locationally. Hawaii is an extremely special example compared to New York. New York, while we say we balance the grid in New York, this grid, as somebody mentioned, it's an AC grid, is interconnected all the way out to the Rocky Mountains. So to the extent where we have overgeneration, it just flows. Electricity just flows. We don't stop it unless you have special devices that do that. Hawaii is an islanded system. They have a lot less, and I keep mentioning flexibility, they have a lot less flexibility. They can't just rely on California to pick up their excess generation. They're not connected to California. They're somewhat connected from island to island. So they are going to have a lot more strict requirements to maintain that reliability than we'd have, where I could see them mandating wind plant, you have to stay within this level of variability because we can't handle anything else because we don't have that flexible system.
Okay, thanks. So I think we're out of time, but I'd like to thank Rob and David and Shayne. And so please join me in thanking them. And then I think these guys will be available for a short time afterwards if anybody has questions, and I'd like to thank you all for attending and enjoy the rest of the conference.